All right, so we are going to go through the rest of our practice exam. So number 22 says determine whether the following is a probability distribution. If not, identify the requirements that is not satisfied. So looking through these probabilities, we know each probability has to be between 0 and 1. And then we know that the sum of all the probabilities has to be equal to 1. So looking through these probabilities, we see we have a negative number over here, so we can already tell that it's not a probability distribution. So we don't have to check if they add up to 1 because it's not a probability distribution. All right, so that's question number 22. We're going to move on to page 5 to number 23. Okay, over here we have a probability distribution given, and it says find the mean of the probability distribution. So the way we do that is we go to Stat, Edit, make sure that your list 1 and your list 2 are cleared. We're going to put our random variable x into L1 and our probabilities into L2. So L1 has 3, 6, 9, 12, or 15, and then L2 is 0.14, 0.29, 0.36, 0.11, or 0.1. Obviously these numbers have to line up. We're going to go to Stat, Calc, 1var Stats. As our list we put in L1, as our frequency we put in L2. Then we hit Calculate. So we've basically used the 1var Stats, L1, comma, L2, and this gives us all the summary stats. So our mean is our X bar, which is 8.22 over here. And then it's not asking for the standard deviation, but if we were to look for it, it would be right down here, the sigma x, which is 3.41. So our answer for this example is C. Our mean is 8.22. So again, you just put the random variables, all the values into L1, the probabilities into L2, and then go to 1var Stats. The next number, 24, a police department reports that the probabilities that 0, 1, 2, and 3 burglaries will be reported in a given day are 0.46, 0.41, 0.09, 0.04 respectively. Find the standard deviation for the probability distribution and round to the nearest hundredth. Okay, so we have our random variable, which gives us the number of burglaries. So we have X over here, which can be 0, 1, 2, or 3 burglaries. And then the associated probabilities of 0.46, 0.41, 0.09, and 0.04. We do the same thing we did before. So we're going to do the 1var Stats for L1, comma, L2. So let's go out of here. We're going to go Stat, Edit, clear out list 2, and clear out list 1. Put in the random variables 0, 1, 2, or 3. Put in the associated probabilities 0.46, 0.41, 0.09, 0.04. Then click on Stat, Calc, 1var Stats, again L1 and L2, L1 for your list, L2 for your frequencies. Hit enter, and our mean is 0.71, and our standard deviation right here is 0.79, rounded to the nearest hundredth. So it's 0.79. Okay, so moving on to question number 25. Suppose that voting in municipal elections is being studied and that the accompanying tables describes the probability distribution for 4 randomly selected people, where X is the number that voted in the last election? Is it usual to find 4 voters among 4 randomly selected people? Well, what is the probability of 4 voters? Well, the probability that x is equal to 4 is equal to 0.04. And usually, remember, when we look at probability distributions, we need to look at the probability that we have at least such an extreme value, which is greater or equal to 4. And obviously, since there's no other outcomes for our random variable, it's just equal to 0.04. This probability is less than 0.05, which is kind of the number we look at in order to determine whether it's unusual. So yes, we would say this is an unusual event to have 4 people. Okay, let's move on to question number 26. It says, suppose you pay $2 to roll a fair die with the understanding that you will get back $4 for rolling a 2 or 3 and nothing otherwise. What is your expected value? Okay, when we're looking for games and we're trying to determine whether they're fair games or not, we have to look at our random variable and our probability. And over here we look at our net win. And what is that probability associated with it? Okay, so we can either win or we can lose. All right, so if we lose $2. So our net win in that case would be negative $2. If we win, we get back $4. But since we've paid $2 for the game, our net win is actually plus $2 or positive $2. We're rolling a fair die, and we win when we roll a 2 or 3. So what is the probability that we roll a 2 or 3? Well, the probability that we roll a 2 is 1 in 6, and the probability that we roll a 3 is also 1 in 6. And there's no way we can roll both a 2 and a 3 in the same roll. So we can just add those two probability, which is 2/6 or 1/3. So the probability that we win $2 is 1/3. Now the probability that we lose $2 would be the other cases, which is we either roll a 1 or a 4 or a 5 or a 6. And obviously that would be 4 in 6. So let me write this down. That would be 1/6 plus 1/6 plus 1/6 plus 1/6, or 4 in 6, which is 2/3. Notice this is a probability distribution because each value is greater or equal to 0, less or equal to 1, and my two probabilities add up to 1. Okay, now to find the mean, I can multiply and then add these two values, or I can again use the one-var stats. So either way is going to work. I'm just going to enter it in a table over here and do the one-var stats. So we have -2 and 2, which are the two outcomes there. And then we have 2/3 and 1/3. Now we're going to do stat, calc, one-var stats, enter, and our mean is -0.67, rounded to 2 decimals. So our mean is the same as our expected value. Another way to calculate that, we could multiply the x times a p of x over here and then sum it all up. This would give us the expected value. So what does this mean? Well, first of all, D is the answer over here, but it also means that this is not a fair game. So on average, when we play this game, we lose about 67 cents, which obviously favors the bank and not us. So that's one thing to consider when you're playing this game. All right, let's move on to the last page. So just a couple more questions over here. For number 27, it says, assume that a procedure yields a binomial distribution with a trial repeated n times. Use the binomial probability formula to find the probability of x successes given the probability p of success on a single trial. Round to 3 decimal places. Okay, so over here we have a binomial distribution. We have n equals 7, x equals 4, and p equals 0.5. And it tells us to use the binomial probability distribution. Okay, so to find out the probability when x is equal to 4, we're going to use n choose 4. So n is 7 in this case. So 7 choose 4 times p to the n to the x power, so to the 4th power, times q to the n minus x, which is to the 3rd power. So let me just write this down. So it's n choose x times p to the x power times q to the n minus x. So my n is 7, my x is 4, so 7 choose 4, which is our combination. We have 0.5 to the 4th power, 0.5 being our p. Since p is 0.5, q is also 0.5. So now we have times q to the power of n minus x, where n is 7, x is 4, so 7 minus 4 is to the 3rd power. So this becomes 7 combination 4 times 0.5 to the 7th power. And in order to find the answer on the calculator, we have to first input our 7. Then we have to go to math, error over to probability, go down to NCR. This is the combination when for 7 objects when we draw 4. Then I'm going to multiply it times 0.5 to the 7th power, which gives me 0.2734. Or over here it looks like we're rounding to 3 decimals. Actually, and that's what it said up here. So this is approximately 0.273, which is answer C. Okay, let's look at the next question. We have a couple more binomial distributions. It says find the indicated probability, round to 3 decimal places again. Find the probability of at least 2 girls in 6 births. Assume that males and female births are equally likely and that the births are independent events. So this is really important when we're looking at binomial distribution. We have a fixed number of trials. We have these independent probabilities that stay the same from event to event. And we have 2 outcomes. Either you can be a girl or a boy. So the probability of a girl is equal to 0.5. which means that Q is also equal to 0.5. Our total number of trials is 6. We have 6 births over here, and we want to know what is the probability that X is equal to 2. So we can either use the binomial formula that we used in the question above, or we can use the binomial PDF. When we use the binomial PDF, we put in the n, we put in our p, and we put in our x values. So the way you find it is under the distributions over here. So you click on second vars, you go down to binomial PDF, you put in the number of trials. So in our example we had 6 births. Then we put in the probability, so 0.5, and the last thing you enter is the x value you're looking for, and which is 2. All right, I'm just looking over here and it says at least 2 girls. So I apologize, this should be x greater or equal to 2. Okay, so let's go back to this. Since we're looking for x greater or equal to 2, that would mean 2 girls or 3 girls or 4 girls or 5 girls or 6 girls. So a lot of different outcomes we're looking for. So generally when we look for all these events and we're looking greater or equal to a number, we always want to look at the complement. And the complement of this would be either 0 or 1 birth. So P, the probability that X is greater or equal to 2, is actually 1 minus the probability that X is less or equal to 1. So over here we have 1 minus, this time since I'm looking for two different probabilities, I can use the binomial CDF instead. The binomial CDF, I first enter my N, which is 6, then I put in my P, which is 0.5, and then I put my largest X value that's included over here, which is 1. So I'm going to put all this in. So let me clear out of this. I'm going to do 1 minus the binomial CDF. So binomial CDF, you go to second vars, arrow down to binomial CDF. So this time I'm going to be 6 trials. The probability is 0.5, and my largest value included is 1. Now in some of these TI-83s, you have to enter this side by side, kind of the way I wrote it over here. So let's go to paste, and we hit enter, and the probability is 0.891, rounded to 3 decimals, which is answer B over here. And sorry, I have to put this just a little bit up so you can see it. So again, looking for the probability of at least 2 girls is 1 minus the probability of at most 1 girl, which is 1 minus the binomial CDF. Enter in N, P, and the largest one that's included over here, and you get a probability of 0.891. So if you have 6 children, you have a pretty good chance of having at least 2 girls. Okay, number 29, so just 2 more questions to go over here. It says, in a survey of 300 college graduates, 56% reported that they entered a profession closely related to their college major. If 8 of those survey subjects are randomly selected without replacement for a follow-up survey, what's the probability that 3 of them entered a profession closely related to their college major? So we have a lot of numbers over here. A couple important keywords. It says without replacement. So we have a survey to 300 students. So we have our P over here, which is 0.56. And what is our N? Well, our N is actually the 8 people selected. Why does it tell us how many people were in the survey? Well, let's see what happens. 8 were chosen out of the 300 people, which is 0.0267. So what that means is we're drawing without replacement, but since we're picking less than 5% of the population over here, we can treat it as though it's independent. So this is really important. We treat it as independent. Since we are considering less than 5% of the population. So because of that, we can use our binomial distribution. If we didn't have those independent events and those independent probabilities, then we could not use the binomial distribution to describe it. So we have the probability of 0.56. We have a sample size of 8, or our N is equal to 8. We want to know what's the probability that exactly 3 of them entered a profession closely related to their major. So that's the probability that X is equal to 3. Since we have just one value, we can use the binomial CDF. You could also use the binomial probability distribution. So either way, our N is equal to 8, so make sure you don't put 300 there. The probability is 0.56. And our X value is equal to 3. Oh, And over here, this should be the binomial PDF, just one value we're looking for. So looking for binomial PDF, we find it under second vars. So go down to binomial PDF. We have 8 trials, that's the ones we consider. Our probability is 0.56. So again, because we're picking less than 5%, we can assume that the probability is the same from trial to trial, and the X value we're looking for is equal to 3. Over here, the probability of that is 0.162, which is option D. And then we have just one more question over here. A die is rolled 9 times, and the number of times that 2 shows up on the upper face is counted. If this experiment is repeated many times, find the mean for the number of 2s. So, wow, what do? We roll a die 9 times. We want to know what is the mean. So what do we know over here? Well, we know it's a binomial distribution. We know we can have either 2 outcomes, which means that either we can have a 2 or we can have not a 2. So my P over here would be a 1 and 6, which means my Q is a 5 and 6. So with probability 1 and 6, we can roll a 2, and with probability 5 and 6, we will not roll a 2. To find the mean over here, we use the formula, so the mean is equal to n times p, which is 9 times 1 in 6. So this is 9 over 6. We can cancel out a 3, which gives us a 3 over 2. So our mean is 3 over 2, which is 1.5. So that's our last question, and so the answer is A. All right, wonderful.